So for this one, we require the software. We require the AERSCREEN.exe. Exe here means executable. It's a short. And then another thing is if it's a .exe file, means that this exe is an extension of this software. You've seen this extension concept before. You've seen it in Word. You've seen it in PowerPoint. If it's a Word document, the extension is docx. If it's a PowerPoint file, it's a pptx. But if it's an exe, means an executable. It's not a file. It's something that can. It's a software that can execute. Now, sometimes some PCs, if it's a foreign exe file, it's something that they don't recognize. It would think this as a virus. So it might be flagged if you have some virus software, antivirus software, and then it scans your PC and finds this and might flag it as a virus, but doesn't mean it is a virus. They just think that it is a virus. So since you know that this is a file software that you need, so you can unflag this as a virus. And these are the 3 executables needed, and we need to put this in a folder somewhere on your PC, and then run the software within that folder. The next executable is the AirMod and also the MakeMed. Now, AirScreen is a software that's able to put all of these other softwares together to generate the result. So this is an additional software, while this AirMod is the main air pollution dispersion modeling software. While the MakeMed is a software with AirScreen, it's used to create the meteorology, to simulate the meteorology, because for AirScreen, we don't require a separate meteorology file. That's what makes it simple, because a proper air pollution dispersion modeling study requires additional meteorology data, more meteorology data from weather station and so on to add in. But AirScreen, because it's supposed to be very quick, it generates its own meteorology data based on what you think is the minimum maximum temperature and wind speed. And then it will just use the worst case scenario to meteorology to generate the pollution profile, air pollution profile. So far, so good, everyone? Yep. Yes?
Yes, doctor.
Okay, thank you. Thank you very much. Now, this is the notes on this. Simple 1 point. You'll be using the same steps. So it's the first test case is the simplest, while the 5th test case or hands-on is the most complicated. So it means that it takes more time. But if we skip some of the steps in the hands-on 2, 3, 4 until 5, means that we already did those points within this. I mean, you're supposed to use the same steps in those other hands-on test case. So that's why I put a note here. Note that you'll also be using almost the same steps for the other cases. Now, the first step, if we need to create a folder and name it AERSCREEN and take note of the path. Okay, let me walk you through this for now. Okay, so the first step here, it says create a folder and name it AERSCREEN. You can name it whatever you want, but if you want to be standard here, we can just use the same name that I put here. I prefer if you create it in your documents folder. You don't create it in your desktop folder. So you can put it in your desktop folder. You can put it in your downloads folder, your documents folder. I have a few things in my documents folder. I don't want to clutter it, so I'll just put it in my downloads folder. Now, the reason why we don't put it in the desktop folder, the one on, I think most of us, most of you, I don't usually put anything in my desktop, but most people, they will put things in your desktop folder because it's right there in front. If we do it there, then it might eat up your RAM and slow down your PC if you have that many, if you have a lot of things on your desktop. So I would suggest you to put things that require like things that work, like models and so on, in a different folder than your desktop folder. So here I would just put it in the downloads folder instead of the desktop folder. So here I need to create a folder. I just right click and then I click on new and then click on folder and then I name it as AERSCREEN. Can you do that now, please? Yeah, do that now. I'll wait. Just tell me when you're done. Okay. So please, everyone.
Doctor, I have a question.
Yes, please.
No. If let's say I want to create the folder, can I create the folder inside another folder, or it should be on the front of the document folder like that?
It can be in it can be a subfolder of the main folder, of the documents folder. It's fine. It's just
Okay,
that
okay, thank you.
yeah, you can. It's just that you will need to navigate into it further. There'll be a additional step later. If it's somewhere outside, it's simpler to reach it. So
Okay, okay, thank you, doctor.
you understand this later when we actually do it. I think I can mention some things about the name of the folder. I recommend not to name the folder with a space. For example, keep it simple as much as possible because we'll be typing this out. You'll understand what I mean later. Keep the name simple, keep the name low caps, and don't put any space for the names. For example, AERSCREEN, then you put a space and doc. Don't do that because you have to somehow type the space there. So don't do that. And if you need to have a space, put an underscore so that it becomes one name instead of typing the space in between the names. So you might not be able to appreciate that now, but later I think soon you would know why I would choose use a simple name, low cap name, so it's easier for us to type this later. So here I already said name it AERSCREEN, so just use this name for now. But if for other projects, your own project, then use the same recommendations, use the simplest name possible, but still informative enough for you to know what it's about. If you want to have a space in between the words of the name of the folder or file, then you put an underscore. For example, let's say I rename this. I want to name it like this: AirScreen Docs. I don't keep this space there. If I still want to have this two word, then I put an underscore, like so, like this. You need to put an underscore to separate the two. Don't leave a space in between. And I'm going to rename this back to the original name, AirScreen. Now we need to take note of the path. Okay, what is a path? A path is like this. This is the path. And then when I say the word path, you know what I mean here. Now for Windows, usually your files will be in the C drive. I think you might have seen this before. You know that you know what I mean here when I say it's a C drive? Yes? No? By default, they use the C letter to for the main drive by default. Although if you have additional drives, like you add in an external hard drive, or you put a thumb drive, you have a second hard disk, then they could name it different drives. For example, D, E, and so on. But the main one would be called C. And then I assume all of you or most of you are going to put this folder in the C drive. For example, your downloads, documents, pictures, and so on. These are all on the C drive because these are the main documents, main folders of the operating system. And then usually the subfolder of this C drive is named users. Although this might be a bit different between you, and even for this new PC that I'm using, it might be a bit different, but usually it's called users with a capital USERS. Then slash the subfolder. This is a different PC. That's why it's called U3 Office. This is the PC that I have in my office that I used to create the slide. But the one I'm using right now is not this PC. So I will need to. This will be different for me for this current PC. And then the downloads folder. Luckily, I actually use the downloads folder for this example. But in your case, you might be using downloads folder as well. And then this is another subfolder, air quality models. Although this air quality models here is not going to be the same because my AirScreen folder here is exactly under my downloads folder, not in the air quality models folder. Okay, so this is not the same anymore. and then the folder that we just created, the AERSCREEN folder. So we need to take note of this path. How do we know what path this folder is right now? Because we just see AERSCREEN, I think we just right click this one, and then we click on properties, and then you'll be able to see the path there. Can you do this right now? Now we copy the executables with the extension exe here, and this software here. Why this software? Because it's here. The required software is this tree for this hands-on one case. We copy this and put it inside the AERSCREEN folder. Okay, so I'm just going to do this now. Just observe what I'm doing, and then later on you can do it yourself. Let me open up my, oops, sorry. Okay. Can you see my Windows Explorer screen?
Doctor.
Yes? Okay. So now I double click on this and go inside that folder. It's empty. Now we are going to copy this AERSCREEN.exe, AirMod.exe, and MakeMat.exe and put it inside this folder. So these files are, or these executables are in ELEARN. So go back to ELEARN and go into this page, AERSCREEN.exe file. And then these are some information here, and then you see those executables, and you download AERSCREEN.exe, MakeMat.exe, and also AirMod.exe. So I'm just going to download from the top. So I copy this one. It's downloading right now. Okay, finish download. Then I click on this one to download the next one, AERSCREEN.exe. Wait for it to finish download, and then the MakeMat.exe. Although you'll be using the others later, but right now we just download this tree. Okay, I see that I've already downloaded the tree executables. I know that this one goes into my downloads folder. Okay, automatically it will go into my downloads folder. So I'll navigate to my downloads folder, and I see the tree executable files just now that I downloaded. Then I copy the tree, and I'm going to put it inside the AERSCREEN folder. So now the tree executable files are in my AERSCREEN folder. Okay, now we've done this step, copy the executables and put it inside the AERSCREEN folder. Now you need to click on the start button on your desktop screen and search for CMD.exe. I'm not sure whether I can show you this. So it says here, click on the start button on your desktop screen. So this is the start button here. Okay. You don't really have to click on this. You can just click on type here to search. So, and we're going to search for the CMD.exe. So I'm going to click here in the type search, and I'm going to type CMD. Okay. Once I type CMD, I would see this command prompt app, and then I click on this application, and you would see this. So search for, we already did this part here, search for CMD.exe, and then we navigate to the path above. So what I mean by this is we go to this folder here using the command prompt. Okay. Although we actually see the folder here on the in the Windows Explorer, but we need to access the folder here inside the command prompt, because AERSCREEN can only run from here. It cannot run from here. You cannot just double click here. I think, I'm not sure, but let's not, maybe you can because things change, but let's not do that right now. We'll just use this way for now. Later on, if this is okay, then we can go back to this. Okay, so how do we navigate the path? Here you notice that the folder structure is given again, the one that you copy and paste just now. So for my PC, there is that C folder, a C drive, and then there's user subfolder and the user in all caps subfolder. And this is not in the AERSCREEN folder by default. By default, it goes somewhere to the main folder. And then we're supposed to navigate from here to this folder here, this downloads AERSCREEN folder here. So let me teach you a few commands. It's just 2 commands. The first command is dir. Okay, let me just type this up here. Commands, important commands. There's a lot of other commands, but you only need to know 2. One is dir, and the other is cd. So dir in Windows stands for directory, and cd stands for change directory. So if you like to see the contents of the folder, like for example just now here, I like to see the contents of this user folder, I can just type dir, press enter, and I will be able to see the contents of this folder user. So here I see there is this .astropy folder, IPython, Jupyter, Lycor, Origin, and so on. And then there's also the documents folder, the downloads folder, the favorites, and so on. Can you try this now? This dir is not exactly compulsory. It's just one way for us to see what's inside the folder, just to view it, not to do anything, not to change the folder. Okay, once we've seen all this, then we know that our AERSCREEN folder, the one that we created just now, the one that we need to navigate to, for me, it's inside this downloads folder. So I would just to go from this folder, from this user folder to go into this subfolder downloads. So now we've done that. We want to navigate into this folder. So keep in mind your path just now. Whatever it is, it's going to be in a subfolder. And then for me, it's going to be inside this downloads folder here. But for the rest, I noticed some of you put into subfolders, and then that's when you need to actually go to navigate to many other subfolders to reach that folder that you've created. So that's what I mean just now. You can actually put it, but it would be more difficult to go inside the folder, but not that difficult. Okay, but for me, if I want to go to this downloads folder here, I would use this this command called cd. I'm going to type it now. cd space, and then the name of the folder, taking note of the capital letters here, capital D, O, W, N, making sure I spelled it right. And then I press enter. And once I press enter, to know that it's successful or not is this additional subfolder in the path. I'm inside my downloads folder now. For me, I'm still one folder behind. I'm still in my downloads folder. I need to go into my AERSCREEN folder. So I will just type in cd AERSCREEN, press enter. Now I see that I'm inside the AERSCREEN folder, and then I type dir to confirm the files are there. So depending on where you put the AERSCREEN folder, then you should type in the cd accordingly. So notice that the point that I gave, if your names, the names of the folders are long and there are symbols in them and so on, it's going to be difficult for you to navigate to that folder. And now to run the model, it's actually quite simple. We just need to type this AERSCREEN.exe and then follow the on-screen instruction. So, and then with that, we will be done with, not really done, it's just that we'll be running the model now. So in the proper folder, let me just show this. In this proper folder here, where the AERSCREEN.exe file exists, we just need to execute that file by typing the name. All right, I'll just to keep with the logic that we did just now, we noticed that the name of the file is all caps. So we just type in the name, AERSCREEN.exe, like that, exactly like this, to run the application. There's no CD or anything because we are running the application here. Don't forget the exe too at the back. And then press enter. Now, now if you are in the wrong folder, if you type AERSCREEN.exe, it's going to say that no file exists, or the file is not found. It's because you're not in the right folder. That's why we need to navigate to the folder before we can run the executable. Top here it says AERSCREEN.imp does not exist. This is fine. This is just a message. It's not an error. All right. Now we are on the screen. It says enter title. So we just need to put in the information here. And the information that you need to put in is in this table. So open the PDF, the one I have opened right now. I think you know where this is. And the information that you need to input into the software is okay. So we just need to type in the information that's in this table here. But for now, we just follow the on-screen instruction. For example, it says enter title. The title says simple 1 point. So I am going to type the title in. Simple 1 point. After I'm done, I just press enter and follow the instruction. The next input is English or metric units. So we are going to use the metric unit. So we just type M. It can be capital M or it could be small m. It should be the same, which means that we are using the metric unit. Press enter. Next, it asks whether we are going to model point, volume, area, area circle, flare, point cap, or point horse source. For this example, we're going to use the point source. So point is P. So type in P, press enter. And it goes to the screen. Can you do that? Okay, for emission rate, we need to input the emission rate in grams per second. If you watch the video, you would know that we need to add in the emission, the amount of pollutants being exited or emitted by the source in the form of grams per second. It has to be mass over time. So it can't be concentration. So there's a big difference between concentration, air pollution concentration, and air pollution emission rate. What we need here is the emission rate, not the concentration. So here it says emission rate in grams per second. We're going to use a simple value of 1. Although this can be any, for your specific project, you have to determine the emission rate first before you can use the model. But for this example, we're going to use a simple one, which is just 1 grams per second. So I'm going to type 1 here, grams per second, and then press enter. And then we're supposed to input the specification of the stack, the smoke stack, or the source. So how tall is the stack? How tall is the smoke stack or the source in meters? So here in this table, we see it's at 10 meters, which means that we need to type in here 10, and press enter. And then ask what is the stack diameter in meters. So over here it says the stack diameter is 0.5 meters, so just type that in. And then it asks for the stack temperature in Kelvin, not in degrees Celsius. This is in Kelvin. If the stack temperature is the same as the outside temperature, we can type 0. Or if it's a negative number for temperature difference, so if the stack is emitting the pollution, the pollutants at a lower temperature than the ambient, then it can be negative. Or we can just type the stack temperature itself. So there's a few ways that we could input the value here, but I'll just keep it simple by just stating that the temperature of the stack is at 313 Kelvin. So this is the temperature that the pollution or the air pollutants are being emitted at 313 Kelvin, which is about 313 minus 273, 40 degrees Celsius. Okay, 313 Kelvin is 40 degrees Celsius, but I'll just put here 313. 313. Don't need to put the K, just put 313. And then press enter. Over here, there's a number of ways that we could input the velocity of the emission. Option 1 is in meter per second. Option 2 is in feet per second. Option 3 is the ACFM. To keep it simple, we just use the m over s, the meter per second velocity, because we're quite used to metric unit or SI units. But if you have the information in feet per second, you can also use option number 2. But in this case, we're going to use option number 1. And the ACFM, what is that? ACFM is this. If you look at the slide, it says ACFM is it stands for actual cubic feet per minute. So sometimes some specifications of stacks or blowers would be given in this unit, ACFM. So if you are given this ACFM value, then we can choose option number 3. But even if they give the ACFM value, we can easily convert it later to meter per second. Although we're not going to use this right now, ACFM, I still need to explain a bit about what it is. The ACFM is slightly lower than the volumetric flow rate. So it's just actually a volume per minute flow rate, not a meter per second or length per time unit. And this is set at standard condition at 0 degrees Celsius. While for the exit velocity and the exit velocity in feet per second, it doesn't matter what temperature it is at. But if it's at ACFM, it is at 0 degrees Celsius. And the volumetric flow rate is independent of density. And it's the same as the inlet cubic feet per minute. And it's generated by fans. So typical range of this ACFM is from 10,000 to 100,000 ACFM. Although we're not going to use it now, like I mentioned just now, we're going to use the exit velocity meter per second. But it's important that you do know this, because you might be given this value for your exit velocity instead of the meter per second value. I suppose this is more commonly given than the other two options. But to keep it simple for this example, we're going to use the meter per second case. All right, I'm going to choose option number 1 based on this table here. Option number 1, exit velocity. The exit velocity is 0.5. It's 0.5 because it's stated here, 0.5. Press enter. Okay, rural or urban? Urban. Population just now was 50,000. Was it 50,000? Yes, 50,000. No, 500,000. Minimum distance to ambient air, 1 meter. Right now we put 1 meter, but actually it should be 100 meters. But I think we just follow this for now. And then no chemistry or pollution or pollutant is not NO2. We're not using the chemistry option. So of course we choose number 1. Building downwash, no. We're not going to consider that for now. Terrain height, no. Maximum distance to probe, we use a default. Although usually when we run this, we would want to model for an area of 10 kilometer radius. In this case, it's just for 5,000 kilometer. 5 kilometer radius. But we're just going to use the default for now. Discrete receptor, no. At this point, flagpole receptor, no. Also, okay. Some of these things might be alien to you because this is the first time you're seeing it, but I'll just explain where I think I can explain within a short amount of time. Let me see if annotate. Flagpole receptor is something like this. Let me just, let's say this is the ground, and then most of the model would, most of the time we are interested to find the concentration at the ground level here at the surface, where Z equals to 0, ground level. But sometimes we like to know the concentration of air pollution somewhere above in the air, not at the ground level. So that's what it means by a flagpole receptor, like a flagpole like this. And then we, like say Z here is at maybe 5 meters instead. We want to know the concentration here. So if we don't want to, if we want to know the concentration at 5 meters above the ground, then we should put yes here. But from my experience, we don't really need to know this. We usually are interested to know the concentration at the ground level because people, human beings would be at the ground and not somewhere here. So that's why I choose flagpole receptors no, because we are more interested on the ground level, at the ground level. So that's why I choose here no. Talking about receptors, the discrete receptors means that if we like to know at a specific point the concentration, discrete means separate, things that are singled out and focused on. So if we want to just look at a certain area or certain position and up to 10 certain positions or discrete receptors, then we can put it as yes. And then we have to tell the model that these are the points that we are interested in. But we don't, this is optional. We could still run the model for the entire area instead of just for the discrete receptors. Usually the discrete receptors are meant for sensitive receptors. For example, you have a source. Let's see, how do I annotate again? This is that location. This is a top view, by the way. We're looking at from the top. Okay, so the stack is here. This is the, we're looking this as if it's a map. Okay, so the stack is releasing air pollution. I'm going to use a different color, I think. So this is the stack, and then it's going to emit the pollution from here. And then we are interested in a certain area, like say here. So we can specify this area here as a discrete receptor. And we can go up to 10. Maybe one of it will be here, discrete receptor, but we need to tell the model the exact point of the receptor. Usually the discrete receptor is meant for sensitive receptor. For example, in this area here, and there is a school over here, there is a hospital over here. So obviously we like to know what is the concentration going to be like at these sensitive areas, the schools and the hospitals or the residential areas. In that way, we specify the discrete receptors for this area. That's the use of this discrete receptor. And for this AERSCREEN model, it can go up to 10 discrete receptors. So no flagpole receptors here. Press enter. Source elevation. Right now, we assume that the stack is on a flat ground, so it's at 0 meters. Okay, minimum temperature here is the temperature of the atmosphere. In this area, in Malaysia or in Indonesia, I'm not sure, but Algeria, the minimum temperature is about 25, 26 at most times. So I choose here in the example 300 Kelvin. So 300 Kelvin minus 273 is 27 degrees Celsius. So it should be about 300 or so Kelvin, minimum temperature. Maximum temperature, I put 307, which means about 34 degrees Celsius. just an estimate. Okay, wind speed. We put it at 0.5. We cannot go down to 0 because it breaks down at 0. So we should keep it at the lowest possible value. Furthermore, in this area or in Malaysia in general, the wind speeds do not go up that high. So most of the time we can assume 0.5 meter per second in this area, unless it's a very windy area and where the minimum wind speed could be 1 or 2, but in this area it's usually 0.5, and it's a conservative estimate if you were to use 0.5 instead of a higher wind speed value, because when you use a higher wind speed value, the concentration of air pollution will be lower because of the spread of the pollution due to the wind speed. So that's why I choose 0.5 here. Anemometer height is a default value of 10, so no need to worry about it that much. By the way, this 10 value comes from the standard use of weather stations. Weather stations would need to put the anemometer at a height of 10 meters above the ground. That's the standard height used for anemometers. So I press enter here. So we don't have to worry that much about this anemometer. Usually it's just 10 meters. Press enter. And these are the part where we need to identify the surface of that area. We are assuming for this particular case it's an urban area. So an urban area would have these characteristics, surface characteristics of albedo to be 0.2, Bowen ratio 0.5, and surface roughness 0.5. I recommend you to watch that video on this surface characteristic video, so that, and then you will be able to understand the choice of the values. Okay. The surface characteristic will affect the dispersion of the pollution. If there is more turbulence generated by the surface due to these characteristics, it would cause the dispersion of air pollution to be more widespread, which is better because the pollution would be lower. So here I just state the values and we just put in here. And then because it's a single user specified value, it's not a table of values, so that's why we just use one for now. So albedo here is 0.2, Bowen ratio is 0.5, and surface roughness is 0.5. We press enter, and then the output. Now this name, simple1point.out, is the name of that output file. The results will be written inside this output file that we name. Notice the extension is .out. This is just, it can be any name that you want to. It doesn't have to be simple one point, just as long as the extension is .out. You can read this too to understand more about this, or to remind yourself that you should have an OUT at the back of this file name. And then we press enter, and then we review the confirmation screen. So here is that window. Check to confirm your inputs. Make sure that all this is correct before we actually run the model. Okay, just now you made some error in one of the... Okay, how do we go back to that error? In this screen, let me just... In this screen here, you go to the bottom, it says AERSCREEN run is ready to begin. Choose option to proceed. Press enter here and then run. Okay, suddenly I see all these extra auto-generated files created. The files of note is this. This one I don't think is important. Not important, not important. This is the input file. This is the output file. And this, I think these three files are important. So this one, I think if you just double click, then you get to see the output. You'll open a notepad. But this is a .out file. You need to, if you click on this file, double click, then it will come out this window. This window will pop up, and you need to choose the application. So the application you need to use is this notepad application. Okay. Now we go to the last part of the simple one point. follow along, you should open Excel now. So run Excel. Okay. And then locate and open the file simple 1.out. So I open, click on browse, find the folder. I think it should be in downloads, not here. The downloads, go to AERSCREEN, and then there's nothing inside the AERSCREEN folder because this is looking for just the Excel file. So click on this one and change it to all files, and you see all the files here. Then you find that simple 1.out, the out file, the OUT file. Click on that, open. And this one will pop up. So it says here, import from row 108. Use the space delimiters. So it's here it states start import at row what? Row 1. But no, we want row 108. So type 108. And then this delimited part here, this is by default, so leave it as it is. And then click on next. Okay, the delimiters part here, don't use tab, use space. And then edit the file to only include distance and concentration. Okay, that's it. And then click on next and click on finish. So now you see the concentration in Excel. This is the concentration. This is the distance. This is the concentration. This is the distance. This is the concentration. So this bottom part here is not that important. I think I can just select all of this and I delete. And then I take this column here, select this part here. And then I right click and cut. And I paste it below here. Okay, why I paste it? Because the concentration actually goes back on top. So we want to make it into two columns with many rows. Again, this is the distance, this is the concentration. Because you want to plot this. You select this two column, and then you plot. You click on insert, and then you plot. I think this is the plot. And then you see the concentration. This is the distance from 0 to 5,000 meters or 5 kilometers. And then this is the concentration from 0 to 600. Then this is the plot like this. So we already did this part here. And then a bit about the output files. Okay, there's a lot of output files just now. We have the AERSCREEN.fil. We don't use this. You can just ignore it. This is the input file, the one that we generated using that on-screen instruction. This is the input file for AirMod. We auto-generate this using the input just now when we were using the command prompt to add in the data. This one is auto-generated. And then the output files, mod out, and this simple 1.out file. This is the result, the one that we use just now. The others are not that important, but they are generated to be used by the model. This PFL stands for profile. This SFC extension is for surface. This is generated by the MakeMat application. And another profile and source from the AERSCREEN application. But these are, you can ignore these files. The one that you need to focus on right now is just a simple 1 point file. Is the PLT file is the plot file. We don't use this for now. The AERSCREEN text is the input and run details, and the makemat text is the makemat input and run. So all this can be ignored for the moment. This one, if it's the max concentration part, so you might be using this later, but not now.